Hello everyone, welcome to my channel Science Learning Point. In our previous chapter, Matter in Our Surroundings, we already learned about matter. We learned that matter is present in all around us and we studied its different states, solid, liquid and gas. We also learned about particles of matter, their movement, the space between them and how matter changes from one state to another. So today we are not going to learn again what is matter. Instead we are going to ask a new question. Is the all matter around us pure? Let's think about something we use every day. Take a glass of water. Is every sample of water exactly the same? What about milk? What about air? What about what about soil? And what about the water in a swimming pool? At first, some of these things may look like one single substance, but if we look at them scientifically, we may find that they contain more than one substance. For example, when we add sugar to water, the sugar seems to disappear. But has it really disappeared? No, the sugar is still there. So today we are going to learn how scientists decide whether something is a pure substance or a mixture. Here we will learn about elements, compounds, mixtures, solution, colloids and suspensions. And we will also learn different methods used to separate mixtures. Now let's understand the word pure. In everyday life, we may use the word pure in different ways. For example, we may say pure water, this is pure gold, this is pure copper, etc. But in science, pure has a very specific meaning. A pure substance contains only one kind of particle. For example, if we have pure gold, all the particles are gold particles. If we have pure copper, it contains only copper particle. A pure substance has a fixed composition. That means its composition does not change from sample to sample. It also has definite properties. For example, a pure substance has characteristic melting point and boiling point. Let's compare this with a mixture. If I mix salt and sand, I don't have one kind of substance anymore. I have salt and sand together so that it is a mixture. Therefore, remember this very simple line. Pure substance is equal to one kind of particle. So now don't confuse pure with clean. In science, pure means only one kind of substance or particle, not simply something that looks clean. Now we understand the meaning of a pure substance. Let's see how matter is classified. Matter can be divided into two main groups, pure substance and mixture. Now pure substances are divided into two groups, elements and compounds. Mixtures are also divided into two groups, homogeneous mixture and heterogeneous mixture. Don't worry if all these words seems difficult right now. We are going to understand every word one by one. By the end of the chapter, this flowchart will become very easy. So think of this slide and as the map of our whole chapter. Let's start with elements. An element is a pure substance made up of only one kind of atom. For example, pure iron contain only iron atoms, pure copper contain only copper atoms, pure gold contain only gold atoms. We represent elements using symbols like iron, we represent with Fe for copper, Cu, gold, Au, oxygen, O2, hydrogen, H2, etc. etc. Now remember something important. An element cannot be broken down into the simpler substances by ordinary chemical methods. Think of an element as a basic building block. Just like a building can be made by using bricks, substances are made from atoms. An element contains only one kind of atom. So if I ask what is an element? You can answer an element is a pure substance made up of only one kind of atom. Very simple. Now let's move to compounds. A compound is different from an element. A compound is formed when two or more elements chemically combine in a fixed ratio. Let's take a familiar example, water. Water is made up from hydrogen and oxygen. Hydrogen is an element, oxygen also an element. But when they chemically combine in a fixed ratio, they form water, which is a new substance. The formula of water is H2O. Another example is common salt. Sodium combines chemically to chlorine to form NaCl, sodium chloride. You can see another example, iron sulfate or other chemicals. The important thing is that the properties of the compound are different from the properties of the elements that form it. For example, hydrogen and oxygen are gases, but water is a liquid under ordinary condition. So remember, chemical combination means new substance. Compound means fixed composition. This is very different from a mixture. Now let's understand mixture. A mixture contains two or more substances that are physically mixed together. Let's take an easy example, iron plus sulfur. Suppose I take some iron fillings and some sulfur powder and mix them. Have I made a new substance? No. The iron is still iron, the sulfur is still sulfur. They are simply mixed together. This is called a physical combination. Another example is a fruit salad. We may have apple, banana, orange, grapes in one bowl. They are together, but they have not chemically combined, and we can change their amounts. We can add more apple or fewer bananas. Therefore, a mixture can have variable composition. Variable composition. The components of a mixture also retain their own properties. And because they retain their properties, we can generally separate them using physical methods. For example, iron can be separated from a mixture of iron and sulfur using a magnet. Mixture means physical combination. If I ask you, is fruit salad a compound? Please comment below. Now, mixtures are mainly two types, homogeneous mixture and heterogeneous mixture. Let's start with homogeneous. Homogeneous means uniform throughout. For example, take sugar and water. If sugar dissolves completely, the solutions look the same throughout. The top and the bottom have the same composition. Another example, salt water, sugar water, air, alcohol water. Now let's look at heterogeneous mixtures. Here the composition is not uniform. Different parts can contain different substances or different amount. For example, oil plus water. Oil and water do not mix properly. We can see separate layers. Another example is sand water. Here the sand remains separate from the water. So remember, homogeneous means uniform. Heterogeneous means not uniform. Here's the useful trick is homo means same, hetero means different. Now let's talk about a very common homogeneous mixture called a solution. Imagine you are making lemonade. You take some water and add sugar. You stir it. The sugar seems to disappear. But remember, it has not actually disappeared. The sugar particles have spread throughout the water. This is called a solution. A solution has two main components, solute and solvent. The substance that gets dissolved is called the solute, and the substance in which the solute dissolved is called solvent. For example, in sugar solution, we use sugar plus water. Here sugar is solute and water is solvent. Another example, salt plus water, salt solution. Here salt is solute and water is solvent. So remember, solution equals to solute plus solvent. This is one of the easiest formula in this chapter. So if I dissolve salt in water, which is solute, which is solvent? Please give answer in comment below. Now let's learn about three types of solutions based on the amount of solute that is dissolved. First, unsaturated solution. Second, saturated solution. And third is supersaturated solution. So, first one, suppose I have a glass of water. I add 1 spoon of sugar. It dissolved. And another spoon, it also dissolved. There is still a possibility of dissolving more sugar. This is an unsaturated solution. More solute can still dissolve. Now let's add more and more sugar. Finally, we reach a point where the water cannot dissolve any more sugar at that temperature. This is a saturated solution. So what do you mean by saturated solution? No more solute can dissolve at that temperature. Now comes supersaturated solution. It contains more dissolved solute than a saturated solution normally contained at the same temperature. It is generally unstable, so let's remember this in a fun way. Unsaturated means I still have space. Saturated, no more please. Supersaturated, I am crying, extra solute. Now let's understand concentration. Concentration tells us how much solute is present in a certain amount of solution. Let's imagine two glasses of lemonade. Glass A has 1 spoon of sugar, glass B has 4 spoons of sugar. Which one tastes sweeter? Probably glass B. Why? Because it has more sugar compared with the amount of solution. So, glass B is more concentrated. We can express concentration using different formulas. One important formula is mass by mass percent. What is mass by mass percent? Mass of solute divided by mass of solution into 100. Let's take the example on our slide. We have 40 gram sugar plus 100 gram water. First find the total mass of the solution. 40 plus 100 equals to 140 gram. Now mass percent equal to 40 by 140 into 100 equals 28.57%. Therefore, the mass percent of sugar is 28.57%. Another formula is mass of volume percent. Mass of solute divided by volume of solution into 100. Don't be afraid of these formulas, okay? First, identify the solute, then identify the solution, then put the correct values into the formula. Now we are going to compare three important systems: true solution, colloid and suspension. Let's start with the true solution. Take some sugar and water. The sugar completely dissolves. The sugar particle becomes extremely small and spread throughout the water. The particle size is less than 10 to the power minus 9 meter. Because the particles are so tiny, we cannot see them. They do not settle down. They cannot be separated by ordinary filtration. The solution is homogeneous. It is generally transparent and it does not show the Tyndall effect. For example, sugar water, salt water. Suppose we have sugar water on the table for 1 hour. Will the sugar settle down at the bottom? No. Why? Because the sugar particles are extremely small and remain distributed throughout the solution. So remember, true solution means very small particles, stable and no Tyndall effect. Okay. Now let's move to the colloids. Colloidal particles are larger than particles in the true solution. Their size is approximately 10 to the power minus 9 to 10 to the power minus 7 meter. A colloid is actually heterogeneous, although it may appear homogeneous to our eyes. Let's take a very familiar example, milk. When I look at milk, it looks uniform. But scientifically, milk is a colloid. Other example is blood, fog, smoke, etc. Colloidal particles generally do not settle down easily, so colloids are relatively stable. But here is one very important property: colloids show the Tyndall effect. That means their particles can scatter light. For example, when sunlight passes through fog, we can see the path of the light. So if you see the word colloid, immediately think Tyndall effect. Now let's learn about the third type, suspension. In a suspension, the particles are much longer. Their size is generally greater than 10 to the power minus 7 meter. Because the particles are large, they may be visible. The mixture is heterogeneous. It is usually opaque. It is unstable. Particles settle down on standing. They can be separated by filtration. Let's take muddy water. When we mix mud with water, the water becomes cloudy. Now leave it undisturbed. What happens? The mud slowly settles down at the bottom. That is a suspension. Another example is sand water. If we filter sand and water, the sand stays on the filter paper while water passes through. So remember, suspension means large particle settling and filtration. This is the easiest way to identify a suspension. Now let's learn about a beautiful phenomena called Tyndall effect. The Tyndall effect is the scattering of light by colloidal particles. Have you ever seen sunlight entering a room through a small window? Sometimes you can see the beam of sunlight, or think about a car headlight in fog. the beam becomes visible. Why? Because tiny particles present in the fog scatter the light. Other examples include light beam throughout fog, sunlight through a dense forest, light passing through smoke. Now we need to remember one very important comparison. True solution, no Tyndall effect. Colloid have Tyndall effect. This is a very common question in exam. So whether you hear which one show Tyndall effect, your answer should be colloid. Okay. Now we know that mixtures contain different components, but how can we separate them? Scientists use different method of separation. Let's learn methods. Number one, first method is evaporation. Suppose we have salt dissolved in water. How can we get the salt back? We can heat the solution. The water changes into vapor and leaves the solution. The salt remains behind. This method is called evaporation. Next method is centrifugation. Centrifugation involves rapid spinning. It is used to separate substances based on differences in density. A familiar example is cream from milk. Another method is separating funnel. This method is used to separate immiscible liquids. Immiscible means liquid that do not mix with each other. For example, oil and water, they form separate layers. The denser liquid stays at the bottom and the less dense liquid stays at the top. So remember some example: evaporation, salt water; centrifugation, cream milk; separating funnel, oil water. Now suppose we have several liquids mixed together. All of them can mix with one another, but they have different boiling points. How can we separate them? We use fractional distillation. One of the most important example is petroleum. Crude oil contains many different components. These components have different boiling points. When crude oil is processed in a refinery, different fractions are obtained. This includes petroleum gas, petrol, kerosene, diesel, lubricating oil and paraffin wax. Think about how useful these products are in our daily life. Petrol and diesel are used as fuel. Lubricating oil is used in machines. Paraffin wax is used in production such as candles. And another important example is liquid air. Liquid air can be separated into nitrogen, oxygen and argon. So the main idea is different boiling points equals to separation into different fraction. Okay. Now let's learn about crystallization. Crystallization is used to obtain pure crystals from an impure substance. For example, we want to obtain pure copper sulfate crystal. So what can we do? At first, we prepare a solution. Then we concentrate it carefully by heating. After that, we allow it to cool very slowly. As the solution cools, crystals being formed. We can then collect the crystal. So a question is, why is crystallization better than simple evaporation in some cases? Because some substances may decompose when strongly heated. Now let's look at another important process, water treatment. Water collected from natural sources may contain suspended particles and microorganisms. The basic sequence is reservoir, sedimentation, loading, filtration, chlorination, then at last home. During sedimentation, heavier particles settle down. Loading helps Suspended particles come together and settle more easily. Filtration removes the suspended particle. Chlorination helps destroy many harmful microorganisms. So the water becomes suitable for further supply and use. Now let's connect this chapter with something we already know from science. There are two important types of changes, physical change and chemical change. Let's take melting ice. Ice changes into water. Has a new substance formed? No. Ice and water both are H2O. So, melting of ice is a physical change. It is usually reversible because water can be frozen again to form ice. Now let's take burning wood. When wood burns, new substances such as ash and gases are produced. Can we easily turn the ash back into the original wood? No. So burning wood is a chemical change. Let's look at some more examples. Burning of magnesium, burning of sulfur, electrolysis of water, rusting of iron. All these are chemical change because new substances are formed. So remember, physical change means no new substance and chemical change means new substance formed. Now we have reached our final slide. Let's put everything we learned together. First, let's compare a mixture and a compound. Mixture is formed by physical combination. Its composition can vary. The components retain their own properties and they can generally be separated using physical methods. For example, iron, sulfur, salt and sand, fruit salad, oil water, etc. Now, compound. A compound is formed by chemical combination. It has a fixed composition. A new substance is formed. Its components cannot be separated by simple physical method. Okay. For example, water, H2O, sodium chloride, NaCl, etc. So finally we learn the difference between physical and chemical change. Okay, so if you remember only two lines from this entire chapter, it will be helpful to you. Remember, mixture equal to physical combination and compound equals to chemical combination. And one more important point is science is not just something written in your textbook. Okay, when you see milk, salt water, muddy water, oil water or ink or rust or petroleum, you are actually seeing the concepts of this chapter in your everyday life. So don't just memorize science. Look around you and try to find the science. Okay, very good. Now you don't have to be afraid of this chapter. Whenever you see a substance around you, just ask yourself, is it pure? Is it a mixture? If it is a mixture, what type and can we separate it? That's how a scientist think. Okay, so always try to be a little scientist. So thanks for watching. Please like, share and subscribe to my channel Science Learning Point for more videos. Thank you. Bye bye.